We are back now, the third part of our afternoon session, new added value through key components. And of course, there has to be an expert presentation about the field of storage technology. And if you happened to visit our Baden-Württemberg pavilion in the last 10 years, there was always a key part, the presentation of ads-tec. This is a medium-sized family-owned company with its headquarters here in Nürtingen near Stuttgart. And so a warm welcome to Thomas Speidel, CEO from ads-tec Energy, and also the president of the German Energy Storage Association. We're looking forward to your presentation. Nice to see you. Nice to have you here. The floor is yours.
Thank you very much. Welcome, ladies and gentlemen, also from my side, to my presentation and to the session Battery Buffered High Power Charging. My name is Thomas Speidel and I'm the CEO of ads-tec Energy. First, a few words to our company. So we started in ads-tec already 15 years ago with the development and production of own lithium-ion battery systems based on the cell. We made our own BMS, including all the software and also the hardware and electronics. And then beginning of 2010-11, we started with large-scale battery systems up to megawatt-hour scales. 2012, we had our first containerized battery system. And then from that direction, we moved also to the charging business because we expect electric vehicles to need a lot of power, even in the distributed grid areas, and therefore not at every site we can set up a mid-voltage system to provide the amount of energy or power we need. In 2018, we started to develop a battery-based charging system for OEM from South Germany. And since 2018, also Bosch is a partner of ads-tec, and they have 39% of the shares of ads-tec Energy. We address three different areas in the business. First, residential, and we call it home and small business. And then second, industrial, and third, infrastructure, which is also EV charging. And even when the grid is not able to support enough power, then we use the battery to store the energy and then push the energy out of the storage into the vehicle when a charging process is needed. Let's come to the core of the presentation, to the high power charger, including a battery storage system for boosting the energy. So first of all, let me describe the rough and the system, and let give me a system overview. So if we have from the grid only a limited grid access and a limited power, then we take the battery as a buffer, and so we load the buffer with the low power, and after the battery is full, we can take the battery energy, the stored energy with a higher power rate, and put it in the electric vehicle. So we can see here, so we have a boosting process from, let's say, 50 to 100 kilowatt from the grid up to 320 kilowatt directly to charge the vehicle. So high power charging can even be provided at locations equipped with a very low or limited grid access. So no grid extension is necessary, which is often expensive. So as you can see on the right side of the slide, if we slowly charge the battery, we can pump the energy we have stored in shortest time directly into the electric vehicle. So the charging process, even at low power sites, can be reduced enormously to a short time. And this is what we need when we drive our electric car. We don't want to wait a long time to get the car refueled or recharged. Here you see our system in real. So the maximum DC charging power of up to 320 kilowatt or 2 times 160 can be provided. And we can distribute the charging power to 1 or 2 dispensers. So the internal buffer enables to boost the limited power from the grid to reach up to the 320 kilowatt to charge the vehicle. We have the possibility to directly connect to the 400 volt low voltage grid, so the charge box can be almost installed at every site, starting from a support of 39 kilowatt up to 110, which is sufficient to install a charge box directly on the low voltage grid. Our highly integrated power inverter technology based on latest silicon carbide technology allows to get enormous efficiency, not only due to a high voltage level on the DC link, but also that the battery is directly coupled to this internal DC link backbone. The design is very compact, so if we want to go in distributed areas, so there's in many spaces there is not enough space to install containers or to install transformer stations. So in this case, we only need very small space to provide a fast charging capability. The dispenser itself has a very small footprint. It's only 400 by 400 millimeters, so the dispenser can be almost installed everywhere. Now I have a closer look to the charge box itself. As I said, we can deliver an output of 320 kilowatt, even at a low power connection to the grid. We have an internal battery capacity of up to 140 kilowatt hours, which is the lithium-ion based battery. And we passed all the certifications, not only for the EU standards, but also for the US. The battery modules itself, they are small battery modules. They can easily be accessed and also be replaced even in the field. We supply up to 2 dispensers per charge box, so they can be separated. And the system includes everything. So this small box contains the inverter, the battery, the HVAC, which means the thermal management, and also the controls of the complete system. In addition to that, the system is also prepared to deliver grid services such as power quality or even grid services, and later on also bidirectional charging, so the content of the battery of the car could be recharged or could be directly sent to the grid. We also included the IT technology, which means security firewalls and communication units, so we can connect the charge box directly to OCPP standard backbone by fiber optics or even copper coupling. The voltage range is pretty high or is pretty wide, so we can support DC ranges from 150 up to 920 volt, which allows us even to support batteries of the future or cars being not available today. The dispenser, let me just say a few words to the dispenser. The dispenser, as I said, is has a very small footprint, so it can be mounted almost everywhere, and it allows the output of 320 kilowatt. It's a cooled cable. It's a water-cooled cable, which provides up to 500 amps, and we are compatible to as well CCS1 or for the US and CCS2 for Europe. The liquid-cooled system is very flexible because we can just deploy the dispenser up to 100 meters from the charge box itself. Very important is the low noise, so we have no noise at all coming from the dispenser, because the dispenser not even has a fan. It's really quiet. So in areas, for example, residential environments, these kinds of dispenser provide really have no emissions as far as noise is concerned. There's a standard 10-inch touchscreen installed and also a RFID reader so that we can directly have access to the charging process and as well to with the communication to the OCPP backend, as I mentioned already. Here's an overview how the installation could be. We see the space and we see the length of the cable. So we can put the box up to 200 meters away from the grid access point. And then between the booster, which is the box, and the dispenser, we have 2 times 100 meters. So the distance between dispenser and charge box can be up to 100 meters, which allows a very flexible installation in many complex installation situations. Now we see how small the complete system really is. We see the box now, it's about 1.2 cubic meters. And the box itself, including the complete inverter technology, the battery, the HVAC, everything is about 2.6 tons. And the dispenser is around 180 kilo, as you can see it here on the right side, as it's pointed out. So we need only very, very less space, which allows us the system to be installed at any location, which makes it possible to really fast charge cars in distributed areas where no powerful grid access is available. And not in every situation we need the high power grid access, because we don't need to charge one car after the other like we do on the charging hubs, for example, at the Autobahn or highway. Here I want to show you a performance example, how to recharge 80% of your car in just 20 minutes, even at such a power limited grid access. So we always say that recharging a car should be around 15 to 20 minutes, and we can now prove here with this example that this is possible. Here we see 3 sequential charging sessions without any derating, and between every session we have 10 minutes pause. And we can see it on the diagram on the right side. We get the power from the battery is pointed out in blue, and the additional power comes from the grid, because we have some grid power being available. And now the red line points out the sum, so it's the total available power from the battery and the grid. And we see that this is going up to 280 kilowatt in this case, which the car in this example requests. So we charged here in this example 3 times after in a sequence around 66.4 kilowatt hours, which corresponds to around 80% of the SOC, state of charge, of the vehicle's battery. So we can recharge in only 20 minutes around 80% of the SOC of the vehicle battery. This is quite fast, and in this case you see the energy which is charged in the car, which is the lower right diagram, and we see the energy, the amount goes up, and then in total it's around 199 kilowatt hours we charged within these 3 sessions, and per session it's around 66.4 kilowatt hours. And a question we often are asked is, how long does it take to recharge the internal battery? And what we can see here, the recharging process with the grid access of around 80 kilowatt is roughly 1 hour and 15 minutes. And since we have installed quite some of these systems in the field, we never came in the situation that ChargeBox ran out of batteries. So the recharging process of the battery with the energy coming from the grid is always going in parallel to the processes that the car is changing, that people are waiting, and that it takes some time between two sequential charging sessions. What we see here is now we have set up a mass production in Dresden, in east of Germany, and we see that now we are able to produce even higher volumes. So between September last year and December, for example, we built more than 300 of these charge boxes and more than 600 dispensers. Up to now, it's over 800. Here you see also some reference installations, and we see that it perfectly fits in different situations we know from our daily life. So it could be industrial park, even at the gas station. So we see here in the middle of the page, we see a gas station which is located in Berlin, Alexanderplatz. And we know from this example that even this battery, which is the highest which has the highest frequency of charging processes, never ran out of the battery. And what we can see on the right picture, so the box is just being in the corner, so you can install it in the corner where little space is left, and then the dispensers with a very little footprint can be placed in almost every corner, or in this case, in this middle field here between the parking lots. On the left side down here, we see it in a country or in an area where even a transformer, you see the transformer house in the back of the picture. And so this solution can even make sense if there is a mid-voltage transformer in a system, but there is not enough power left to provide, for example, 300 kilowatt or 2 times 160 kilowatt charging infrastructure. The picture in the middle, in the lower side of the picture of the slide, shows industrial site, and we more and more have the experience that people or guests or even employees who are driving electric cars, that they don't want to wait for hours. So if they just pass or visiting the company for 1 or 2 hours, then they are happy that they can recharge the car within 20 minutes or 30 minutes. On the right side, we see installation on a utility site in east of Germany, and so are many sites now, not only in Germany, which are equipped with this technology. So let me just show you another application which we call a mobile high power charger, and it contains exactly the same technology but in a different setup. What we see here is we call it a charging trailer. The charging trailer is a standard, let's say it's on a trailer for a standard truck in Germany or in Europe. And this one contains a battery which with more than 2 megawatt hours of energy capacity and 10 charging points, 10 fast chargers. Each of them can provide 320 kilowatts. So on this trailer we can provide, or with this trailer we can provide 3.2 megawatt charging power distributed on 10 outlets. And so why do we need this? The applications are temporary solutions offering high power charging in an infrastructure which is not equipped with a high power charger infrastructure for 100% or 365 days per year. So for example, during holidays we have a higher amount of charging sessions or driving events. We support a lot of driving events, marketing or press events, or even festivals. So just imagine there are festivals and a lot of people are coming with the electric vehicle, and just for a few days you need more charging power, so you are not able to extend the grid. But in this case, we can use the charging trailer. And this is exactly the same technology, the same inverter technology, the same controls, and the same cooling system. It's flexible. in setup and installation because it's mobile. There is individual planning, so we can take it everywhere around Europe. And we provide a 24/7 support and on-site service. Here on the next page, you see this in live. So we see the sidewalls can be automatically be folded up. So normally on the road it's closed, and then if you have positioned the trailer, you just open the wings automatically. To recharge the battery in the trailer, we need just a 400 volt low voltage grid access, so 3 phases for 50 hertz. And we support 1 to 6 inlets, each taking 125 amps with a standard CEE plug. So the recharge process can be done almost everywhere. So the maximum recharging power is 500 kilowatt, and so we can recharge the complete trailer within 2 hours. In addition to that, the trailer supports an island mode, so without any grid connection, we can just offer a charging infrastructure like a power bank on wheels in this island mode, and then provide up to 10 charging sessions in parallel. 5 EVs per side and 10 in total, each up to 320 kilowatt, charging in parallel. Also the cables, the same as in the charge box, is liquid cooled and has a CCS2 plug. So the dimensions of the trailer are standard, as you know it from the common standard of the trucks in Germany or Europe. And even the weight, we do not, or we are within the weight specifications of the standard truck specification in Europe. Here are some examples where the trailer has already been used, and we see the Porsche events. So we supported the Taycan launch in Barcelona, and for example, for this event, there have been 7 trucks in parallel providing 21 megawatt charging power at the same time. So 70 cars can charge in parallel, and each car up to 320 kilowatts. So to enable such a charging performance or power on a site, normally you have to build up quite a significant grid and power. What we also have, or what we see on the pictures, we have some experience even in cold countries. So we did the winter experience in Finland. So even with cold temperatures, the trailer is working and can supply the energy for the charging process. And what we always see is as more electric vehicles will come into the field, into our daily lives, and this will happen the next year. So when we see the big OEMs now bringing more and more vehicles to the market, so the demand of charging, and especially fast charging, will grow. This is for sure, because we don't want to wait for longer as it really needs to get back on the road or to come home earlier. And driving does not mean waiting. And this is important, so we expect more and more supercharger, not only at the Autobahn or at high power grid stations. So we also expect it in distributed areas, or in this case, even with the mobile solution, which is mounted on a truck and can be provided to any location where it's needed or temporarily needed. Thank you for your attention. And if there are any questions open from you, Mr. Fischer, for example, then I'm happy to answer.
So, first of all, thank you very much for being with us today. To be honest, I especially liked your example of a mobile solution needed for a festival, people gathering for some purpose. Yeah, at the moment, hard to imagine, but we all hope that it will be possible soon. Yeah, I think you pointed out a lot of people always say, as you pointed out, it's not only about high power charging on the motorways, but you showed a lot of different use cases for that. So I think it's becoming much more important in the future, and it's a growing market. Of course, we will have a study out soon.
Okay.
About the market development of charging infrastructure.
Yeah, we even see cities. So if they have a pizzeria or a museum or whatever, and people are just passing by to get a pizza or to go to the museum or to a concert, then after 1 or 2 hours they want to leave. And so in this cases, if you come from outside, you have to recharge within minutes, and nobody wants to drive to the Autobahn and lose 1.5 hours just to get there and to charge and get back.
So
okay.
Our
Thanks
time is up. Thank you very much, Thomas Speidel, for being with us. And hopefully next year we talk live in Hannover, maybe having a coffee together. Thank you much for being here.